Need a solution to talk on your industrial network? Let's look at ControlNet. ControlNet is an open industrial network protocol and is managed by formerly Open DeviceNet Vendors Association, or ODVA. ControlNet is based on a token-passing bus control network, and we will talk more about how this part works as we move along. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. ControlNet utilizes the Common Industrial Protocol, or CIP, for the upper layers of the Open Systems Interconnection, or OSI model, that has 7 layers: physical, data link, network, transport, session, presentation, and application. The designers of ControlNet adapted the CIP layers of transport, network, data link, and physical to fit the needs of the ControlNet network. ControlNet was designed to provide reliable high-speed control and I/O data transfer by using programming that sets the logic to specific timing over the network. It also provides for critical messaging that does not rely on timing to be executed without interfering with the transport of control and I/O data. The types of devices that the ControlNet network talks to are programmable logic controllers, I/O chassis, HMIs, personal computers, drives, and robots. It is typically used for redundant applications and/or applications that work best with scheduled communications. ControlNet has a data transfer rate of 5 megabits per second and is in the mid-range of the 3 popular networks, with Ethernet IP ranging from 10 megabits per second to 1 gigabit per second, and DeviceNet ranging from 125 to 500 kilobits per second. Now, let's move on to the physical media of ControlNet. ControlNet cables are RG6 coaxial cable types with BNC connectors. BNC connectors can either be a twist-on and locking type or a more rugged design that is a screw-threaded type for more harsh environments. You can choose cable types such as flexible, direct burial, or plenum-rated based on the application and environment that your network will be used in. There are some applications for ControlNet that require longer distances and may use optical fiber in the cabling. The maximum cable distance for ControlNet cables is 1,000 meters, unless a repeater is used. There can be a maximum of 5 repeaters, 10 for redundant networks. ControlNet can support a maximum number of 99 nodes on the network, and the repeaters do not use node numbers. Therefore, they don't count as a part of this maximum number. When you are designing the network, the topology options for ControlNet are trunkline dropline, star, or tree. It's time to continue with the other physical media of the ControlNet protocol, such as taps, terminating resistors, segments, repeaters, and bridges. Taps are devices that allow you to connect nodes to the trunk via a drop cable. There are several types of taps: T or Y, straight and right angle, that lets you have flexibility in configuring your ControlNet network. A 75 ohms terminating resistor is required at each end of the trunk cable. Segments are collections of trunk cable and taps that have terminating resistors at each end. The length of each segment is dependent on how many devices are attached to the trunk. Repeaters can be used to lengthen the ControlNet networks by connecting them in between the segments. Bridge devices are communication connections between networks that only forward packets of network information, but not any actual I/O. Now that you have seen the basics of ControlNet, let's have a look to the other layers and get into the specifics of how it works. As I stated earlier, it's based on a token-passing bus control network, which implements a logical token ring through a coaxial cable. In ControlNet, the nodes are assigned a MAC ID address from 1 to 99, and each node also knows the address of its predecessor and successor. Each node has a scheduled time which is determined by a token. While the node has possession of the token, it transmits data frames until it reaches the end of its transfer, or the token reaches its time limit. Then, a new token is created and is passed on to the next logical successor. There may be nodes that do not have any data to transfer, and in this case, it just passes the token on to the next logical successor. The process is then repeated until all the nodes have cycled through the logical circle, and then it begins again. In ControlNet, only one node can transmit at a time, which will prevent any collisions of data from happening. If a node stops transmitting and does not pass the token, the ControlNet protocol has provisions written into it that will regenerate the token and send it to the next logical successor. The data link layer is where the timing for ControlNet is done through an NUT, or network update time, that is based on a fixed and repetitive time cycle. The NUT can be set to a duration from 2 to 100 milliseconds and have three major parts: scheduled, unscheduled, and guard band. In the network and transport layers, ControlNet has two forms of messaging: unconnected and connected. Unconnected messaging is used when establishing connections or for low-priority messages that do not happen frequently. Connected messaging uses settings in each node, such as frequent explicit messages or real-time I/O data. ControlNet also uses RIP, or requested packet intervals, to determine how often you want I/O data to be transmitted during the scheduled NUT. To sum it up, the NUT tells you how often the entire logical ring or network is updated, and the RPI tells you how often the devices ask to transmit on the ControlNet network. Some of the advantages of a ControlNet network are high speed. It can be strictly scheduled and have deterministic data transfer, built-in support for fully redundant cables, and very stable and reliable. The disadvantages are, the cost of hardware can be higher, and troubleshooting can be more difficult than other protocols. In my experience, if ControlNet is set up properly, it can be very stable and reliable, and requires very little maintenance. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.